So this is the idea. You have a triple integral, and it's got an r squared sine of theta d r d theta d phi. And so how do we apply it? So the idea is, suppose you want to create a sphere. So you know, along the polar axis, theta can go from 0 to pi to pi. That's a straight line. So theta can go 0 to pi. And so you form a semicircular arc. So the integral will be the angular part. They also call it a solid angle, d omega. That's equal to sine of theta d phi. But let's worry about the sine part. So you get sine of theta d theta, and you integrate that from 0 to pi, or minus pi by 2 to pi by 2. But let's try 0 to pi. So do that to 0 to pi, and we'll get a minus cosine theta. This is equal to a minus cosine theta from 0 to pi. If you evaluate that, you'll see that is equal to 2. That's half. That's a third of it. So now let's go to the next page. And what we find is, again, we had a semicircular arc. This is theta. So now, this is the azimuthal plane, the phi plane, and it can go from 0 all the way around to 2 pi. So basically, you have this semicircular arc, and now you kind of revolve it around to form a circle. So you sweep it around. That way you kind of form a sphere. And this is in phi, the azimuthal plane. So the integral of phi is, so you call it d phi, it goes from 0 to 2 pi. So what you get is just phi, you evaluate it from 0 to 2 pi, and what you'll find is it's just 2 pi. You put it all together, so then you get d omega is equal to sine of theta d phi. Theta goes from 0 to pi. Phi goes from 0 to 2 pi. And the theta part from before, that is 2 times 2 pi for the phi part, and you get this solid angle is equal to 4 pi. Then what you find is, then you got the radial part, so you get an r squared dr times sine of theta d phi, and again 0 to pi for theta, 0 to 2 pi for phi, and then let's say 0 to r for the circle part. So the r part just gives you r squared dr. Integrate that, you get r cubed divided by 3. So you put this all together, you're going to get, from this triple integral, you'll get r squared dr sine of theta d phi. You'll get r cubed over 3 times 4 pi. So you'll get 4/3 pi r cubed, which is the volume of a sphere. So that's kind of basically it. Let's suppose instead of a sphere, now you just have a hemisphere in one quadrant. So what does that mean? So it means that theta goes from 0 to pi by 2, because now it's at 90 degrees. And phi goes from 0 to 90 degrees, which is also pi by 2. So what you'll find is the solid angle part, double integral of sine of theta d phi, they both go from 0 to pi by 2. 0 to pi by 2. So sine again is cosine theta. It goes from 0 to pi by 2. And you'll also get a minus, and you'll also get the phi part going from 0 to pi by 2. So you get a pi by 2 for the phi part. So you multiply that together. This is minus 1. You just get a minus pi by 2. Let's change pages. So you get for a hemisphere, basically being a sphere in one quadrant, you get this. Pi by 2, sine of theta, d phi, you'll get, you just get pi by 2. Okay, you multiply that, and you'll see. Then you multiply by the r part, r squared dr, so triple integral again, sine of theta, d phi, you'll just get, again, you'll get 1 third r squared times pi over 2. So you'll get pi over 6 times r cubed. So you get 1/6 pi r cubed. And in a sphere, there's going to be, that's just like 1. So it's 8 of these basically. It's basically 8, 1, 2, 3, 4, 5, 6, 7, 8. So it's like 1/8 of a sphere. So to get the total sphere volume, you gotta multiply this by 8. So if I multiply this by 8, 6 times 8, 48. Well, I'll figure out later. But that's kind of the idea. So the main thing is, somehow I made a mistake. That is probably it. Let me do one more. So let's do a hemisphere. So again, it goes from 0 to pi, and then the angle part, the azimuthal part, goes from 0 to 2 pi. They go for a hemisphere, 0 to 2 pi. So the angle part is going to be a minus cosine. It's going to be, again, integral sine, so either minus cosine from 0 to pi. That's going to be 2 times phi. It goes from 0. The polling will go from 0 to pi by 2. So it's going to be a minus 1. It's going to be a 1 times 2 pi times 2 pi. So we do that, we're going to get 2 pi. And with the radial part, we're going to get out of space, but we're going to basically get, this is confusing, but we're basically going to get 2/3 pi r cubed, because that's kind of it. And again, 2/3, so for a hemisphere, doing this and then going halfway around to get a hemisphere, well, sorry, it should only be pi actually. This is kind of confusing. But that's kind of the idea.